Hello, my name is Ortiz, and my project is on creating an application for distinguishing deepfakes using frequency analysis. Deepfakes are videos or images created using a process called deep learning. The process of deep learning utilizes artificial neural networks to learn how to create better fakes. In order to find these fake images, image processing is used. Image processing can be anything from changing the tint of an image to recognizing a certain object within the image. This project focuses on images within the frequency domain. Fourier's theorem states that any stream of data can be transformed into frequency values. My project attempts to solve the problem of deepfakes becoming more and more common and harder to distinguish, which increases the spread of misinformation. The goal of the project is to transform an image into the frequency domain, then create an algorithm to identify the fake images. Then create a user interface so that the program can be easily used by anyone. The first step is to download the Java IDE and Android Studio, which allows me to code in a virtual environment. Then I create an image library of both fake and real images so I can test my program. Then I use the discrete cosine transform to create a function to transform the images to the frequency domain. And then I have to create a function to find the curve of the natural images within the spectra. And then then I have to create an equation that utilizes the equation of the curve for natural images to identify deepfakes. The program is then tested on the images that I gathered, which is 80 images in total of 40 real images and 40 fake images. Then create a user interface using Android Studio so that the deepfake analysis program can be easily used. The equation of 1 over f squared was originally derived and then later optimized by my program to create a new equation as shown in the slide. This equation represents the log 10 of the frequency values for the natural image. Fake images were found to have an average distance of 0.391 or greater than the curve of the natural images, while real images had less than 0.319 distance from the curve. This algorithm had a 65% accuracy rate within the testing data. In conclusion, my program was partially successful with a 65% accuracy rate. I hope to get over 70%. However, due to the long runtime of 2 minutes per image, I was unable to test that many images. It took too much processing power for my computer to be able to handle, so I couldn't do a lot of testing and optimize my equation more. The obstacles and limitations. So I had a large number of loops within my program. This was caused due to the DCT, which has multiple loops within it, due to the summation the double summation that is necessary to summarize the cosine functions. This was a major cause of the increased runtime, as well as the analysis that occurred later. The runtime then allowed for fewer images to be tested, which limited the accuracy of my program. I had to then decrease the image size to be able to run the amount of images that I ended up running, which was 80 images in total. In future studies, I could implement hardware programming or parallel processing, which could reduce the runtime. So hardware programming could be used to burn the certain processes that my program would utilize into the hardware, so then these programs would run much faster. And parallel processing would then separate each of the processes and run them all at the same time, so then the program would run faster. This method could also be used to find deepfakes on social media. which could help prevent the spread of misinformation. However, the runtime would have to be reduced for this to be applicable. Thank you for listening to my presentation. I hope you found it interesting.